Hi, I am Prem Mishra, and in this video I'll demonstrate my solution for the autonomous AI agent assignment. This application is built using Fast API and Grok API. It accepts a natural language request, and the agent autonomously generates an execution plan and then executes each task one by one. And later it also performs a self-checking using reflection, and then it finally generates the Word document. And I'll first demonstrate the application with two test cases and then briefly generate you the architecture. So let's just reload it, and let's just perform the first test case using a simple prompt. So we have this prompt. So this is the agent endpoint. So till the agent creates the document, let me walk you through the code base or the architecture. So the very first thing that we have is roots. So this file defines the main agent endpoint. So what it does, it is orchestrates the complete workflow of the autonomous agent. So the request is first received, then it validates the input and then calls the planner for the execution plan. After that, it calls the executor to perform each task, then the reflection service, and so on. After that, we have parentic models to validate the request, the models. Then we have prompt files to pass through, and then we have this planner. So what this planner.py file does is it generates the execution plan. So the very first thing it does is it sends the user request with the planning prompt. We have this planning prompt with us. So it sends the user request with the planning prompt to the agent, and it also handles and validates the return JSON task list, and finally returns the execution plan for the executor to follow. So this is the planner.py, and then we have executor.py. What it does is it loops through each task one by one. Whatever the planner has sent the planning execution task, it loops through each task one by one and performs one task. It also maintains the execution history with timestamps and a small delay to respect the API rate limit, and also includes error handling here to deal with minor errors. And it also sends the previously generated content in each step. And then we have Gemini service. Initially I was using Gemini API, however later due to rate limits I switched to Grok API. And we then have reflection.py. What reflection.py does is it implements a self-checking mechanism. Like once the document is generated, it sends back to the LLM for final review, and the model checks the completeness, or you can say grammar or professional quality, and if everything looks good, it returns pass, otherwise it returns an improved version. And this was also my chosen engineering improvement because it improves the quality of the final output. And yes, then we do have validation.py. So what it does, it checks if the user input is valid or not. It contains if it is null, or it contains white spaces and all. And then we have some utilities, and yeah, that's about the code base and the architecture. And you can see here the agent has created the final output with the execution plan. You can see the execution plan here, status completed, and the document with the document number 36D. So we can see it here, 36D. So you can see the agent has prepared the document plan correctly. And now let's see for the complex plan. So this was for the simple task, and now for complex task, let's see how the agent performs. So while it executes, let me tell you the issue that I faced, like the issue that I ran into. So what happened was, I ran into a configuration caching issue. What happens when the changes in .env were not reflected at the runtime? So what I did to resolve this issue is by I forced the environmental variables to override, like here in config.py you can see what I did. I did override is equal to true, so now it enforces environmental variables to override, and I force the services to read the configuration dynamically instead of caching it at startup, and that I did using Python property getters. So you can see here in Gemini service, you can see the Python property getters. So it loads the environmental variables dynamically at the runtime instead of caching them. And if I talk about the engineering trade-off that I made, so was choosing autonomous planning over a deterministic workflow. So what I did was, instead of hard coding the document generation steps, I let the LLM create the task list dynamically based on user request. So now what happens is, the agent is flexible enough to handle different types of document. Like if there are, let's say, proposals, meeting minutes, or let's say technical design. So now the agent is able to see the technical design without changing the code. So that was the engineering trade-off. And this has some downside. Like the downside is that the number of API calls can vary. So to keep it efficient and prevent excessive token usage, what I did was I limited the generator to plan only 3-4 high level steps. Like in previous, like let me show you in the response. So the agent is taking a bit time, so let's wait. So here you can see only 3-4 high level tasks for agent to plan, and here you can see the complex task has been done, and the document number is 3B8. So let us see how it has generated it. 3B8. So you can see now the agent has planned successfully and correctly the complex task as well. So yeah, that's it.